Hello everyone, welcome to my channel Chemical Engineering Knowledge. In this lecture we will discuss about some important points about the density, specific weight, specific volume and specific gravity of fluids. So first of all, what is density of a fluid? Density of a fluid means that mass of a fluid per unit volume. So density is nothing but it is mass per unit volume. This is the mass. This is M is the mass and V is the volume. So mass divided by volume is called density, and this is the rho. So density is denoted by rho, and rho is equal to mass of the fluid divided by volume occupied by the fluid. So mass per unit volume. Density of water, the density of water, of liquid water is 1000 kilogram per cubic meter at 4 degrees centigrade. So similarly the density of other liquid is similarly the density of different liquid is different from each other. So usually the density changes with temperature. So density changes with temperature. So density is nothing but it is the mass of the liquid or mass of the gas or mass of the fluid divided by volume occupied by that fluid. So mass divided by volume is density. Now there is another term which is called the specific weight. Specific weight of the fluid. So a specific weight is nothing but it is weight per unit volume. So weight per unit volume. It is denoted by gamma. And gamma is equal to weight divided by volume. Weight of the fluid per unit volume. So the weight or the force applied on unit volume of the fluid is called the gamma or specific weight. And we also know that force, the unit of force is Newton, and the unit of volume in SI is cubic meter. So it can be also written as Newton per cubic meter. So specific weight is nothing but it is the force which applied on unit volume of the force of gravity. The force of gravity which applied on unit volume of the fluid is called the specific weight of the fluid. So similarly there is a relation between the density and specific weight. Density is equal to specific weight divided by acceleration due to gravity g. So this relation can also be written as that gamma is equal to density of the liquid and the acceleration due to gravity. So this is a relation between the specific weight and density. The relation between specific weight and density. So this is the relation between specific weight and density of the liquid. Now the relation between, as we already discussed, the relation between the density was equal to, this is the density and this was the specific weight of the fluid, and this is the acceleration due to gravity. Now we know that this gamma, from the above discussion we know that this gamma is the specific weight, which is the force exerted by the fluid, exerted on the fluid by gravity. So the force exerted on unit volume of the fluid is gamma or specific weight. So we will put N divided by V in this place. So N force per unit volume, and this is the G. G is the acceleration due to gravity. So we know that this is the N is nothing but it is the force, and V is the volume, and this G is the acceleration due to gravity. So force, the unit of force is the unit of force is Newton, and volume is cubic meter, for example in SI case, and the acceleration due to gravity is, it is acceleration, and the unit of acceleration is meter per second square. So meter per second square. So meter per second square. We also know that the Newton, 1 Newton is equal to 1 kilogram meter per second square. So this relation can also be written as this density relation. This relation can also be written as density is equal to this 1 Newton is equal to 1 kilogram meter per second square. So 1 kilogram meter per second square, and this is the second square, and this is the meter cube, and this is the meter. This one is meter cube. So this second square cancel with second square, this with this, the meter cancel with meter, and this is the kilogram per cubic meter. So the density, so we also proved from the unit, from the dimensions. The kilogram per cubic meter is nothing but it is the density of the fluid. So similarly, this was just so we also proved the unit of the density with the help of specific specific weight. Now there is another term which is called the specific volume. Specific volume of the fluid. So specific volume is nothing but it is the volume occupied by unit mass of fluid. So volume occupied by unit mass of the fluid. Volume occupied by unit mass of fluid. So it is the volume occupied by unit mass of fluid. Volume occupied by unit mass of the fluid is called the specific volume, and it is denoted by this small v. So this is the volume occupied by unit mass of the fluid. So the unit of volume is cubic meter and mass is kilogram. So it is kilogram, it is cubic meter volume occupied by unit mass of the fluid, which is nothing but specific volume. And if we from the density, we know that the unit of density is kilogram per cubic meter. So specific volume is just the reciprocal of density, because density is kilogram per cubic meter while specific volume is cubic meter per kilogram. So density is inversely related to the specific volume, or specific volume is the reciprocal of density. So this one is the another relation between density and specific volume. Now there is another term which is called, the specific volume is usually used for the gas. For example, if you draw the PV graph, so this is the specific volume and this is the pressure. So if we increase pressure on the gas, then the volume of the gas will be, the specific volume of gas will be decreases. So this is the relation between specific volume and pressure for the gases. Now there is another term which is called the specific gravity. The specific gravity for the fluid. The specific gravity for the fluid. So what is the specific gravity for the fluid? The specific gravity is denoted by Sg, specific gravity, and it is a dimensionless ratio. So it is for liquid, the specific gravity is the density of the liquid, divided by density of liquid water, at standard condition, at STP, standard temperature and pressure. Standard temperature is usually used 1 atm or 1 bar, and the standard temperature, the standard pressure is 1 atm, and the standard temperature is usually used 15.56 degrees centigrade. Usually engineers use 15.56 degrees centigrade, and physicists use this temperature. Physicists use 39.2 degree Fahrenheit as a standard temperature to determine the specific gravity of the liquid. So the specific gravity of the liquid is nothing but it is the density of the liquid divided by the density of the liquid water. Suppose if the specific gravity of a liquid is 0.7, then what will be the density of that liquid? Suppose we have some organic solution or some oil or some petrol or diesel sample, and the specific gravity of the petrol is 0.7, then what will be the density of petrol? So at a standard condition and pressure. So as we know, the density of liquid water is 1000 kilogram per cubic meter. So simply multiply with 0.7. So it will be the density of the liquid. Petrol or diesel will be equal to, suppose petrol density of petrol will be equal to 0.7 multiplied by 1000, which is 700 kilogram per cubic meter. 700 kilogram per cubic meter. So when the specific gravity of a fluid is less than 1, when the specific gravity of a fluid is less than 1, then the liquid will be lighter than water. If the specific gravity of a fluid is greater than 1, then that fluid will be heavier than water. So suppose if we combine the water and petrol or water and diesel, then water will be heavier because specific gravity of water will be large as compared to specific gravity of petrol. So suppose this is petrol and this one is the water. This is the water, liquid water, and this one is the petrol. So the petrol sample. So the specific gravity of the liquid petrol is less. Suppose it is 700 kilogram per cubic meter and water is 1000 kilogram per cubic meter. So the liquid water will form a layer at the bottom of the container, and the lighter petrol will form a layer on the top of the liquid water. So this is the just introduction to the specific gravity of liquid oil. Now the specific gravity for gas can also be written as the density of the gas which we determine, and the specific the density of gas divided by density of the air at STP, standard condition and standard temperature and pressure. So the density of gas divided by density of air. Usually the density of air at 20 degrees centigrade, the specific density of air at 20 degrees centigrade is 1.2 kilogram per cubic meter. So this value is known to us at 20 degrees centigrade. And suppose if a gas, if the specific gravity of a gas is 0.8, and what will be the density of that gas? Simply multiply 0.8 with 1.2. You will determine the specific gravity of the density of that gas. So the specific gravity of gas is equal to the density of gas divided by density of the air at STP. So the STP condition for air will be the pressure will be 1 atm or 1 bar, and the temperature will be 20 degrees centigrade. So you can use 15 degrees centigrade, 20 or 25 degrees centigrade. So there is no strict rules on that. So this is the specific gravity for the gases. So in this lecture we discussed some terms, specific gravity for liquid density and other terms. So thank you very much for your attention. If you are new to the channel, please like and subscribe.